Welcome to Tech Talk Thursday, Season 3, Episode 10. Averatek manufacture a range of chemistries used in PCB manufacturing. One of their latest solutions is called Mina, a surface pre-treatment applied to aluminum tracks on PET that enables soldering of components to pads during the assembly process. Here to discuss this new technology with me is the company CEO, Harris Basit. Welcome, Harris. Nice to see you today.
Nice to meet you, Trevor.
Yeah. So let's start off with telling me what the benefit is of using aluminum pads and tracks on PET.
Well, there's several benefits, but the primary benefit is really about cost. Aluminum on PET can cost 40 times less than copper on polyimide, maybe 10 times less than copper on FR4. So the substrate with the pattern traces is just absolutely the lowest cost that you can get of any substrate, and it can be less than 20 cents per square foot, 20 US cents per square foot. And so there's the cost is the first thing, but there are other advantages. For example, aluminum is a much better reflector than copper is. So if you're using it for a LED lighting panel, you'll get a much brighter reflection from the substrate than you would if you had polyimide or copper. Mm-hmm. It's much lighter than copper is, and so for even the same conductivity, the weight can be far less. So for things that need to be much light or flexible, it's hard to beat aluminum on PET.
So it's got greater conductivity than copper. Is that what you're saying?
Well, it's not greater conductivity on a cross-sectional basis. So if you have the same thickness of aluminum as you do of copper, the copper will be more conductive.
Right.
But if you put the same weight of aluminum as you do of copper, it'll be much thicker than the copper and much more conductive than the copper. So you can actually match copper conductivity with much less weight. So a result of that is that every high tension, high voltage transmission line or power cable that's strung, from telephone cables is aluminum, because copper is much too heavy, and you can get equal or better conductivity with much less weight. So where weight is the issue, you can get much better conductivity with aluminum. Where just thickness of the metal is an issue, then copper is better.
Right, I get it. I see. So
aluminum on PT is not the only use for Mina. So Mina is really a generic, solder to aluminum type of application. So we use it, and some of our customers use it in other places. For example, if you have a high power device that has a thermal pad, and you want a very direct, low thermal resistance path to an aluminum heatsink, you can solder the thermal pad directly to the aluminum heatsink and have a purely metal-to-metal connection, no thermal grease, no other interface layer between.
So it acts like a thermal interface material, then.
It acts like a thermal short, effectively, and so that works for, high power switching applications, for RF power amplifiers, and other devices that generate a lot of heat that you want to be connected to. And you can also use it just for structural applications for aluminum, connecting to other metals or to itself.
Right. So this is a pre-treatment that goes on top of the aluminum. Does it work with any other board finishes?
Yes, but it doesn't need them. It's designed to work directly with bare aluminum. So, you take the bare aluminum, you treat it with Mina, and then either a few minutes later or a few hours or days later, you can solder to the place that you treated as if it were copper, for example. So you can use, whichever solder you prefer along with that. So it's not really sensitive to the finish, and typically we advise people not to put any finishes on it because you save money. Right there, you don't need the expensive zincate or Enig or Enipig finishes and that's one of the main advantages of it, is that you can eliminate those things and solder directly to the bare copper.
So how easy is the process then? Is it something that takes a lot of time, or how easy is it?
It's quite easy. I mean, there's a number of ways of applying it. There's two steps to the Mina. One is you have to somehow dispense it onto the aluminum, and that can, and, typically we do that with just a printing process if it's a circuit board, but you can also dispense it with a syringe or any other mechanism that gets a very thin layer onto the aluminum. And then there's a drying process, which can be done slowly in an oven, or with an air knife. It can happen in a couple of seconds. And at that point, it looks like just a white film on the aluminum, and it will stay there inert, inactive chemically for a long time. And you could apply solder on top of it. And then as you reflow the solder, at near the reflow temperature of the solder, the Mina becomes chemically active. And it will, at that point, scrub the oxides off of the aluminum, allowing the solder to make a joint to the aluminum. And then as in the reflow cycle that cools back down, the Mina is either completely gone, sublimed away, or completely inactive. So there's no chemical activity of Mina left after the reflow cycle. Okay. And what that means is that even though you might have a very thin aluminum trace, there's no danger of it being eroded away or reliability issues over time from some residual activity of the Mina. We've seen that. Yeah. I'm sorry, go ahead.
Yeah, I was going to say, what sort of temperature range then does it work over? And does it work with all types of solders?
We've tried it with many different types of solders and not really had a problem. The choice of solder is really based on other things, like, for example, what temperature can your substrate handle? PET typically doesn't handle high temperatures, so we prefer low temperature solders when we're working with PET, unless you're using some special techniques to prevent the PET from getting too hot, like optically heating the solder or something like that. But so the choice of solder and the soldering temperature and the reflow profile is largely driven by the substrate material, which drives the choice of solder. And Mina itself is not that picky about what you do.
Okay. So as I mentioned earlier, it's a pre-soldering process. Is the process best done at the fabricator's facility, or is it better before it leaves the factory, or is it better done at the assembly house?
So it can be done at either location. And we're not trying to really push one or the other. And it may make sense for different manufacturers to do it in one place or the other. There's some benefit to doing it as soon as possible before, or as late as possible before the actual assembly. Because once you apply the Mina, as I mentioned, it's a white film, and it's quite stable chemically. But if the aluminum on PET trace is mishandled, or you can rub it off or scrape it off, and so if there's a chance that there's going to be some handling issues or something in between, it's better to apply the Mina immediately before you do the assembly process. But it doesn't chemically, it's not required. It's just a matter of any potential handling or mishandling in between.
Right. It could be, if it's mishandled, it could be physically damaged, but it doesn't degrade over time.
Well, no, not that we've seen. I mean, we've tested it after weeks between the application of the Mina and the assembly process. We don't recommend that because we haven't qualified it into an indefinite period. So you really shouldn't be applying it, months before you want to use it. So even weeks is probably too long, but days is fine.
At Nordson Asimtech, we provide more to our customers. It's not just about our leading-edge fluid dispensing and coating equipment. It's about custom solutions for your application. More means helping you select the right equipment and configuration, setting it up to ensure your success, and providing ongoing support.
Okay, so let's talk very quickly about applications. Power aluminum is very commonly used for power devices. LEDs would be another one I would think of. What other sort of applications do you think this is suitable for?
So yeah, I mean, there are sort of two major categories of applications. One is the one where you're cost sensitive, where you want to have the lowest possible cost substrate with patterned metal conductor. And, those are, of course, RFID applications. There's other smart tag applications. There's LED. Then these are low cost LED lighting panels, right? Where the LED lights are not generating a lot of heat, but you want very large area to cover your entire ceiling, for example, with this LED lighting panels. And so there's those types of applications. Now, even there, we're finding some applications that in the automotive industry, some of our customers are working there where they're still quite concerned about cost and getting the cost way down. So in the drivetrain parts of the electric vehicles and areas like that, we're finding applications of these technology as well. So there's that. And then there's the other case, which is where you're concerned about connecting heat sinks or other high power or heat dissipation devices to high power devices. And so that's another area. One of our customers is using it for high frequency cabling, and they've got methods to do that. And so there's a number of different ways that you can use it. Really, it's about aluminum. Aluminum is sort of like the balsa woods of metals, right? I mean, it's really very easy to use and very inexpensive. So because aluminum has so many uses, for example, if you want to connect a grounding strap to an aluminum chassis or the housing of a system, you can do that with this. There's a number of other types of, just very straightforward uses of aluminum and thus of Mina, because soldering is well known, it's reliable, people understand it. Aluminum is also, ubiquitous. And so the ability to marry soldering and aluminum in a simple manner is really the advantage that we're bringing here.
Right. So you're known to be a company that develops chemistries and then licenses them. Are you selling this as a license, or are you selling this direct to end users?
No, we are selling the Mina chemistry directly to end users, to assembly houses, to OEMs. The licensing is mostly done in our other businesses where we license the manufacturing that's based on our chemistry. But in all cases, we are selling the chemistry. We don't license the chemistry itself. We license the manufacturing processes that utilize the chemistry.
Right. Okay. So do you have a number of use cases out there at the moment using this Mina product?
Yeah, I think I've gone through a few of them already. There's some uses in high frequency cabling. There's uses in drivetrains of automobiles, electric vehicles. We have some medical applications. Yes, I guess they are medical applications, and also LED applications. And then just a sort of a smart tag, very low cost RFID type of application.
Great. Okay. Well, it's certainly a novel way of producing boards, and it's a nice new technology. So, Aris, I want to thank you for coming in and telling us about it today.
Thank you, Trevor.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.